Good afternoon. Hello everybody, welcome to Multipath TCP Part 2. Thank you all for coming. The normal request, we need a note taker please before we can start. Somebody able to take some notes or join with somebody in the Etherpad? So we need somebody to volunteer to take some notes, please. I'm going to apply my random. So thank you very much to Quentin, Quentin and Olivier, who'll take the notes between them in the Etherpad. Maybe when people make a comment at the mic or something, they could go to the Etherpad and help with the accuracy of your name and your comment, since that's collaborative editing. Now, is somebody able to monitor the Jabber? Rolf, could you keep an eye on it again? and welcome also to the people in Mptcp. So I have, if you're on Mptcp, I have a big red button here. So if you want to talk from Mptcp land, I get the chance to push the big red button, which I haven't done yet. So I'd welcome your comments because I'm looking forward to seeing how well the red button works. Right, we have the usual note well. I should have started by saying I'm Philip Eardley and encourage other people to say their names at the mic. Yoshifumi is remote, I think. He couldn't make this meeting. So the usual note well, please note well. I forgot in our first session to just put up the status of the various documents. So our use cases and operational experience, which is information, was essentially finished quite a while ago. There were a couple of tiny bits which have just been completed. Thank you to Olivia and the authors for that. And it's now been submitted to the AD. I submitted it incorrectly first time. I now think I found the right way of submitting it, or the new way of submitting it. I don't know if Mia's here, can't see me. Oh, so you should now have it properly rather than not. We are still working on the BIS document. So just a reminder, the plan is to last call that as soon as possible. But we won't send it to the ISG till we've got a bit of implementation experience. We've got an item about Mptcp enabled middle boxes, which we'll probably talk about in the chartering discussion later. And there's a paragraph in the charter about implementation advice, which we agreed to remove, I think, 2 IETFs ago. But we still need to work out how to do that. I don't think I have the power to, so I will work with Mia on that. Just one slide summary of what happened on Monday. We had consensus to bump the version number, and then we had a couple of interesting drafts which I think need further discussion. There's various things which we suggested to add to the BIS, so more discussion about what of those to add would be very welcome on the list, and just you know, between people, obviously face to face, use the time here. So today's agenda. So in a moment, Bart and Med asked for separate slots, but they've done some thinking and merging, which is excellent. So they're doing a kind of combined slot. Bart talking about use cases and motivation, Med talking about deployment scenarios. So that's really good, really interesting. Olivier's talking about, on behalf of Benjamin, who couldn't be here, about the Mptcp API work they've been doing. We've then got a short kind of advert slot from Chuck. Chuck, are you here? Hi. About NFS. So he's come from the NFS area, network file systems, and that's about can Mptcp help with the problems they've got. So that'll be like an advert, and then at the end of that we'll try and work out who's interested and when we might have a side meeting to continue the discussion, maybe later today. Runa's then going to talk about the slow start thing that they've been working on. We heard about a couple of IETFs ago, and then it would be nice to have some time to talk about rechartering or possible rechartering at the end. So we have this first combined slot about sort of link bonding and the plain mode work. So Bart, you're up first. It may work. Oh, tell me, and I'll try and.
I'm Bart Perens from Proximus. So, as Phil introduced,
is that working?
I don't think so.
Oh, it is, yeah. Start close.
Okay, so I'm Bart Perens from Proximus. As Phil introduced, we currently have 2 drafts on Mptcp proxies, or what we would call like network-assisted Mptcp, and we have aligned a bit to see how we can have a merged solution. As part of the event, we'll the short discussion afterwards. I think it's good to explain why we want to have this. You can go to the next slide. So, what is the use cases that we see for network-assisted multi-pod TCP? We actually have 2 main use cases. The first one is actually in case you have multi-pod TCP enabled user agents to allow them to have the benefits for of Mptcp when your remote hosts are not yet Mptcp capable. This is actually already part of the current charter, so I'm not going to discuss that much in detail right now. And then we actually see also the scenario when neither of the pod ends are actually supporting multi-pod TCP yet today, to have some of the benefits of multi-pod TCP in the access networks by actually having twice the proxy on both ends. So this will be the main scope of the next part of the slides. So the rationale of this actually from an operator and implementation point of view is that we have very little control of neither the remote end servers or the software running on the host. That's why you want to go network assisted. Okay, so this works. So why do we need this in the access networks? The reality is that even while a lot of us operators are working on rolling out higher speed access networks, you want to put fiber to the home, fiber to the curb, we still face limitations on increasing the bandwidth to users, and we'll have some detail in the next slide with that. This might be limitations due to permits, this might be limitations due to technology challenges once you further from the street cabinets, but actually for increasing the upstream and the downstream. Next to that, we also have a couple of additional use cases, like you can build backup services which rely on multi-pod TCP, or we also have a couple of operators that want to look at a faster service turn-up. Initially bring up your service on a licensed or unlicensed radio spectrum, and while the technician still had to come to install your fixed line service. So combining such different access networks is being worked on also in other SDO, in the broadband forum. It's currently a working text. It's IETF 348. It's close to be finalized over there, and the terminology used there for this is called hybrid access. So we'll use that consistently in the rest of the presentation. Yeah. So one of the benefits, and we come back to that later on, is so when you say we want to improve things, it's typically we want to improve things for an existing service. Typically, as an operator, not building a new service. And, having a technology that allows us to do that by limiting the impact in the rest of the network is really a strong benefit for an operator point of view. So this is to give you, it's one example, it's an example with DSL. So technology is advancing. You will see when you go from ADSL to VDSL, we have significantly increased download and upload speeds. When you go with factoring, you can go to 100 megabit, 200 megabit copper, but this is typically limited to very short distances from street cabinet. The further you go from a street cabinet, actually that speed decreases a lot. And actually with the most newer technology, you can attain much higher rates, but you also see that actually the speed decrease also goes much faster. So in order to offer that same speeds on a single network today, as operators, we have to go to a significant higher densification. This means putting more sleep cabinets, finding permits from the different authorities for that, putting fiber in there. This is something that takes time, it takes investment, while we actually also have other networks, and we would like to see how can we better leverage other networks already available, do resource pooling of that, and provide a better service to actually our users. So the scenario of hybrid access, what we just described, it's something that's already been actively looked by operators. We have showed here a map in a number of countries where there is already some public announcements of operators working on this, doing pilots with this, or deploying exactly in a real field environment. Today, mainly in Europe, a bit in Asia, but you can also say there is actually a lot of interest and lab trials by a lot of more operators which have not gone public with that. At the same moment, there is also strong interest from a number of equipment vendors. You will see a number of different ones that are co-authoring one of the two drafts, some of them actually in the room as well. So our statement is here, there is actually a strong demand here, both from an operator point of view and a support already from an equipment manufacturing point of view to build solutions that combine two access networks. So when you, this is the reference architecture for hybrid access, and then with including the Mptcp scenario for that. So when we define this in the broadband forum, we introduced two new terminologies. We actually have on the CPE side, the home gateway side, we introduced the term HCP, hybrid access CPE, which has a function to split and recombine traffic on the two access networks. In this case, it's been shown as a fixed access network and a mobile access network. Here it's mobile. This can as well be unlicensed spectrum. You can also have scenarios. There's some operators working on combining multiple fixed access lines. So this is not strict. You can do. In the network, we had a concentrator function. This is called like HAG or hybrid access gateway in the forum terminology. And as you can see in the picture, it's, well, some would call it a proxy. It's not really an application proxy, not really translating protocols as well. It's more like we terminated in TCP, we start Mptcp subflows, and we terminated back in TCP to the final destination host. Obviously, assuming here that both ends do not yet support Mptcp. If one of the ends would already support Mptcp, you actually go back to the first slide on the introduction, where you only have a single end proxy, and ideally you would have the solution that can cover both needs with a single type of implementation. So when you work with hybrid access, why do you believe that multi-path TCP is a better solution, or a solution that fits actually the requirements that we're looking for from an operator point of view? When you have a mobile network in licensed or unlicensed spectrum, and actually today are also in the fixed network, the characteristics of those networks today, they no longer fixed. On a mobile network, your latency and your bandwidth that you can acquire on it is highly dependent on the load and the older users active in the cell. You know this on Wi-Fi, it's actually the same thing on LTE. Actually also on a fixed network, in the old days, fixed network, you used to have a quite fixed speed on, for example, your DSL network. With newer technologies have increased speed on these lines. They have become much more sensitive to interference of other cables which are on the same cable in the street. So we can no longer rely on the fact that you have a fixed bandwidth on either of the two peers. So we need some way of flow control and congestion detection to deal by splitting the traffic on the two links. And this is something that Mptcp delivers us natively on a per subflow. At the same moment, using Mptcp will also, for us, limit the overhead. We don't have to do additional encapsulation. It's not like a tunnel. And compared to some pilot setups that some operators have done today, you could also do this with SOCs, but when we do SOCs, you have a high latency for your initial session stuff setup. This is something we can avoid by doing this directly on Mptcp. Other benefits is that we don't necessarily need additional addresses on the two peers or an overlay IP address in the tunnel. We avoid stacking congestion control. And we can split a single flow over multiple access networks without breaking it. The two drafts, and we combine immersion, will also actually cover a number of different deployment models for operators. So, okay, this is just a slide showing the chattiness of deployment with SOCs and some of the constraints it gives. This is what we already introduced. We actually want to use Mptcp in a transparent way in the access network without any dependencies on either the host in the home network or the server. We assume here it's actually TCP. We terminate in a transparent manner TCP on the home gateway. We reinitiate it as Mptcp with multiple subflows on access networks. And we again transparently, at least to the end user point of view, terminate this on the hybrid access gateway to go back, reinitiating it in TCP to the final server. Again here, assuming both ends do not yet support Mptcp. The right leg could as well be again Mptcp, or if the device on the left would already support Mptcp, it could go past through on the first device. So in the beginning, today we have two drafts. We have the draft of Mohammed plain mode, which has already been discussed in previous sessions over here. And I have my draft assistantly also submitted. In the end, we want to archive the same thing in both drafts. It's actually just a different deployment model in a network. It's mainly in how do you want to steer the traffic, if you look in the diagram, in a way to get it back to the hash. And both models might actually fit depending on an operator requirement. So we have sit together and we think we can accommodate it to have this in a immersed scenario. The drafts also allow already today a number of different options, and a couple of things which are today but mandatory will become optional. It has an option for encapsulating auto protocols, including UDP, and either on the hash we can retain the original IP addresses that were assigned to the end host and have them go transparently reusing the same addresses to the internet, or we can local pool mapping, basically a one-on-one NAT, if that's what an operator wants. But there is no obligation or restriction. Yeah, as you mentioned, to cover the use cases, we will make a joint draft. So this is the plain mode option, which is part of the draft of from it. Exactly, additional Mptcp option which is used in a connection establishment, the scene packet. There's a number of fields, so which are actually optional. So you will see we can add the option actually twice in the specification. Why it allows us to, if you want to do traffic steering, we can embed the original destination address. You will write the IP header to the IP address of the concentrator and restore the original address back at the concentrator. This is one option. If the concentrator is already on pod, we might not have to do that. So the address option, which is today there, this will become an optional thing in the next version of the draft. Yeah.
Do you mind if I ask a clarification question?
Sure.
On that previous slide, what does the last bullet mean?
That you can actually add the option twice, because you have the address field and the D field. So depending on the flag of the D field, you will embed the original source IP address or the original destination IP address. What is the use case? If you go here, say the hash is somewhere in the network. We don't put any assumption in advance of what is the location of it. We need to have a way from the CPE to steer the traffic to the hash. In order to do that, we might rewrite the other IP destination IP address to the IP address of the hash, so that way we can explicitly steer the traffic to the hash. But obviously, we need to restore it back to the original destination IP address. That's one way. The other one is when on the CPE side, or also on the side, we might want to embed the original source IP address of the LAN and have the packets going out with one IP address of the CPE on the mobile leg or on the fixed leg. So we have the two scenarios, and in avoiding having two fields, you basically just add the field twice. Actually, option twice. Just clarify for you.
I think I've able to see that. So are you intending that you use more than half the time?
Yeah, we agreed to.
Okay, because you are.
Matt was fine that I was presenting his part.
Okay.
I will ask him to come over here if you need help. So then we have a slide covering what was changed in the plain mode draft since last IETF. So there was some clarification on how UDP flows were handled. So that actually means that similarly there was a question on the UDP fragmentation, which was clarified. It was also added on the destination IP addresses that we should not accept packets on the concentrator when the destination IP addresses are multicast or broadcast. We should be transparent for things like CGN. Yeah, and that we can automatically do the checks and calculation with UDP. There's more questions on this. And then there was a couple of questions on the mailing list that still had to be answered on the plain mode. There was, I understand, a question from Yoshi to compare the plain mode draft compared to the other solutions. So this is a slide created by Matt on this. which highlights the key differences between the different approaches. We also mentioned some of those earlier on the slide, why I believe that an Mptcp approach has benefits, sorry, in encapsulation. I think this is a bit of a repeat of that. There was a question from...
So if you go back a few slides where you said the changes since last IETF, what the first one, why is it necessary to bound one TCP connection to one UDP flow? That just causes unnecessary use of ports. We would like it to be able to carry traffic for the same system, not based on the port, because the port is being passed.
Matt, you want to take this one?
Yeah, this is in the context of this use case, which is like hybrid access. We don't have this kind of limitation of the port usages, so that means that we don't want to have another means to demultiplex connection inside one single Mptcp connection. So if we associate just one UDP flow to one single Mptcp connection, we are done. There is no extra processing to be done from for the CP and for the concentrator itself. But for your use case that you want to achieve is different than this one, which you want to have a direct communication between the client and the server, that you want to exchange UDP flows or that belong to a given application. But because of you have some needs, you want to use Mptcp connection between this client and the server to send your UDP generated traffic. This is another use case, which is not the one that we are covering in this draft. So as you can see, the next slide we mentioned that yes, we understand that you don't need, for instance, this address mapping between that to be embedded in the option itself. So this option can be used for to signal what you want. Perhaps you will need to inject in every packet this option if needed in your use case. But in our use case, we don't inject the plain mode option in every packet. We send it only in the same message of the initial subflow, and then we are done, because we maintain a state in the CP and also in the concentrator. But this, I think these are details, but we can,
I think the wording needs to be changed, because right now the wording says there has to be a one-to-one mapping. And so what you are telling me is that's not necessary. I could send, if I send another option, then it would have the port number, and the protocol number could also be different.
Yes, but what I'm saying is that in this draft we have limited the scope, because there are several variations and it's really rich, and we wanted to focus on one single implementation, which is the stateful one, in which we communicate to the concentrator, to the CP, the information which is required to forward the packet upstream. So to do that, we decided in this specification to avoid that sending this information every time I have to send the packet upstream. So we send it only once and we maintain a state. If we have an optimization to do something which is really stateless, in this chain, you have to send the plain mode option in each packet. But this flavor is not specified in this draft, because we declared that this is out of scope of the specification, and people who are interested on the stateless mode, we are more than happy to work with them in another draft to specify how we can use the plain mode option for the stateless flavor.
I think it's not indeed.
That would conflict. You know, you're saying in this draft that there should be a one-to-one mapping, but then again, you're saying in another draft that I don't have to have one-to-one mapping. I'm saying in this draft, you can say if you don't want, you can have.
We can discuss about this. This is a detail that are not yet the core of this.
I think it's not necessarily conflicting. I think here on one side we're going to specify the plain mode option, and then we're going to document a specific use case for the use of it. And we are already accommodating some parts to allow it to be reused in additional use cases. That's why we also make the address field optional. I think you're free to use the same option, and I think we are facilitating it to make it usable for other use cases to avoid someone else. Yeah.
I'm Margaret Cullen from Painless Security. Just for disclosure, I am one of the co-authors and worked on one of the GRE mode drafts that's being used as a proprietary solution. If we go back to the previous slide. I don't want to quibble about the exact wording of this. I think really you kind of want 3 columns. You want GRE, and then you want the 2 different modes you can run Mptcp in, because I also want you to add some rows, one of which is TCP connection is end-to-end, another of which is load shares UDP traffic. And the answers are different because if you're, there's certain things you, in the Mptcp case that you have to do for UDP traffic that you don't have to do for TCP traffic. And I think that this isn't a good enough picture of the whole situation. I am working on a considerations draft, trying to compare the different solutions in this space, and I would love to get some input from you guys. There's also at least some mobile IP solutions in this space that should be compared. And so, you know, I'm going to be presenting that draft in INT area and also at the Banana BOF on Thursday night. So if anybody would like to come and talk about, I mean, I think this gives me some new criteria to add to that document, some new considerations to add to that document, but I also think you're leaving some of them out of this slide. So
we can work on that. I mean,
Alan Ford, is there anything Mptcp specific at all about this proposal? It strikes me as it's just a zero round trip time tunneling protocol in a way that says everything that follows this option is blah. That's not Mptcp specific, is it? Oh, am I missing something?
I'm not sure I understand correctly.
the part I think of as TCP specific is where they take the TCP flows and they turn them into Mptcp flows and then turn them back into TCP. That's pretty
But that's
Mptcp
separate
specific.
from the protocol that's being discussed here. That could be the
Separate from the actual, the option definition?
Yes,
Potentially, yeah.
because we've got two proposals here that seem to be being merged. One was a transparent one, which is a proxy can sit in the way, and as long as both ends know about it, then it does an Mptcp in the middle, and so on. The plain mode option is an option that just says everything that follows this is actually targeted for this target. So we're struggling to see why this is relevant to here.
I think Wim is probably going to say.
Wim Hendricks from Nokia. Even in the transparent option, in the transparent mode, we need we want to use this option to actually tell that if a flow originated from a client, that you don't have to do this Mptcp. The Mptcp proxy shouldn't do anything with that with the flow.
So the issue is here.
So we want to add the option to indicate that we are in this proxy mode, even for transparent, in the transparent case. Otherwise, you cannot distinguish an Mptcp connection initiated from the UE on the left side versus the one from the home gateway. So in other words, for both transparent and, let's say, not transparent, we want to use the same option.
It's an indicator flag at that moment. It's an indicator flag, and depending on the length of the option, we can also use it for the steering of the traffic or optionally for encapsulating
Which is
the
not in the
protocols.
draft right now, by the way. So.
This is in the
Okay,
to
we
be
seem to
merged
now have
draft.
3 separate proposals trying to be merged into one here. I've read the plain mode draft, I've read the transparent draft. They seem very different, and now we're trying to merge them, and now we've just said that there's a use of a signal that's not documented.
Yeah, so that's why we present. So we had a discussion before this presentation to actually say we made a comment about the fact that even in the transparent mode we need an indication to indicate the fact that a flow would be originated from UE or the proxy in the middle. And as such, we agreed upon using the plain option to do that. And as such, we said, okay, why don't we then make one draft, where this plain mode option is able to cover all the use cases and all the deployment cases. So in other words, you can deploy it in transparent mode. You can deploy it in a, let's say, semi-transparent mode where with the destination IP or the source IP address, you actually do steering and stuff like that. So that's why we merged the draft. Or we are going to merge the draft.
The message I'm taking is that there are, we could do with a simpler explanation of what the different pieces are and which ones, and how the pieces relate to work here. It seems quite difficult to get a grasp of the different suggestions.
Yeah, in the merged draft, basically say the different deployment modes, and say how to use the options in each of those modes. So then you can. It's better to. It will reflect better to see how they are used in each of those different scenarios. But we use them in all the different scenarios. Some with just as an indicator without any
So
idea
the
of
line is
information,
closed
and
after
sometimes
Rolf. Sorry. After you, Rolf, the line is closed. Yeah. After you.
Okay, Alfred, just to respond. So, yeah, okay. Now, I see what we're trying to get at here, and I think we're making a lot of assumptions without having seen what this merge proposal looks like. I would caution quite heavily against wrapping a lot of stuff that is generic into an Mptcp specific protocol here. As I said, there's nothing about the plain mode proposal that's Mptcp specific. And the transparent one was, and now you're saying you need an indicator. That's cool. Let's work out what that means to have an indicator and maybe almost separate that from any signaling that's required for the encapsulation model.
So one of the questions I have about this, and I'm trying to kind of guess what the merge draft looks like. So let's assume it's an option and then a few deployment modes in which that option will be used for the moment, right? Just give me a terminology to use, right? Within each deployment mode, will the impact on the MTU be constant? Is it like you'll always be adding one option to every TCP connection, you'll always be adding two options to every TCP connection, or how? I'm wondering about what the MTU impact is of this and whether or not it'll be constant through a flow. I also heard maybe we only do it on the SYN packet, send the option. So could you just talk a little bit about that? Because I'm not sure I understand what it's like a pure question. I just don't understand what it would be. So.
Okay. So it's a little different question at the same moment. So optionally, we can have up to twice the PM option. I think in most scenarios, you only see the option 2. It's only the scenario in case you would both do steering and you would actually have to.
On every packet?
No, you only have to do it on the SYN packet, and then you create a state on the hack that you can actually relate to that. So you don't need to have that MTU impact on all your packets.
UDP traffic, what happens? In the case where you're encapsulating it somehow. Never mind, because people can't hear me. I was just trying to ask a leading question, but so on TCP, you get one or two options on the SYN packet, and I think I understood that in some modes you'll be putting one, in some modes you'll be putting two, but you probably won't get a gateway that puts one on some and two on others.
Yeah, and the length of the option might depend depending on the use case. If you do a transparent mode, it might be just the first mode. If you do steering, you have the address field. It can be v4, it can be v6, depending on the length, and you have option leave in the port. So
right, and in some
really
cases where things don't put any data in the SYN packet, we probably won't see any MTU impact. But in cases where they do, they might get a lower MTU indication than is actually available, and we'll have to figure that out. But then there's, with the UDP traffic, that gets encapsulated somehow, right? And I'm trying to understand if, like, how the end nodes are going to understand the MTU here.
The same header, so you would have a constant MTU impact.
Right, so every packet would have this. Every packet in UDP would have one or two of these options. Is that the idea? Or we don't know. We haven't quite figured out how the UDP. We don't quite know yet. Is a perfectly reasonable answer. I don't think the draft has been fully.
Yeah, I mean,
written, right?
I think there are lots of questions, and we need to move on. And the line was shut after Rolf, unless Lars is exerting some coloured dot.
You want to go first?
It's not a question, that's why I thought.
All right, so I think the concentrator, Rolf Winter, so I think the concentrator is a heavy-duty middle box, and it's doing a lot of stuff to, so we talk about options, for example, right? It's not a real option because you propose to put it in the data. It's not a TCP option as in the option space, it's in the data, right? You propose to put it in the data, in the payload of the packet. It's just between boxes that, so, but that's a problem. If any of this leaks, right, there might be an end host in there that is doing something with it. So there's a lot of things that make me uncomfortable. If it doesn't work, if it works, it seems fine. Just if it doesn't work, there's a lot of failure modes that you don't talk about at all in the document.
Last second, two quick statements. Statement one, so when did this become a tunneling working group? And can you get back to the red thingy, to the diagram with the red stuff on it? So I'm still shell shocked. The one with the clouds that were red. That one, yeah. So I'm still shell shocked from the quick path this morning, but I will point out that quick with multipath will deploy it on the left there way before you ever have a home gateway that does this stuff. So why shouldn't the home just exploit the different IP prefixes it's getting and let quick or the endpoint do its thing? You know, it seems like this is a little too late.
No, that was very naughty, Lars. And I'm sorry because we are.
Yeah, given that you made one exception, I think that you can do 2 exceptions. Yeah, so yeah,
Go on, man.
yeah,
I'll let you do that.
Yeah. So thank you for being kind. Yes, I've answered to the 2 questions. Your question about the UDP handling, this is something which is detailed in, we have a lot of details in the document to explain how we can manage UDP traffic inside Mptcp connection. We don't have any tunneling. What we are doing swapping of the headers. We are replacing the UDP header with a TCP, an Mptcp header. And the plain mode option is only inserted in the SYN packet of the initial subflow. And then there is nothing which is repeated in the packets. We are indicating the protocol identifier in this plain mode option. So that means that the state that will be instructed in the concentrator on the CP will indicate the protocol type set to UDP. So all the flows.
No,
yeah, but that's yeah. So that's in the draft. For the fragmentation, there is also, this is mentioned in the draft. We have two options there. The recommendation, which the first one, which is inspired from the current design team from the routing area, which say that the recommendation is to increase the MTU in the managed network. And what we are doing here is managed networks. The two, we are under the management of the same network. So we are recommended to increase the MTU and the CP set and the concentrator to avoid fragmentation. But in case there is a problem with MTU, you cannot tweak that. We have specified how to do the fragmentation for all the cases.
It's a controlled deployment within an operating
Exactly,
environment.
yeah.
Olivier, you're up.
And for the second,
And Olivier, you're up. Sorry,
yes,
we haven't got time to keep going.
Okay, so I wanted just to answer, but I forgot the question anyway.
Carriers want control, Lars.
Just while Olivier's comment, Margaret, do you want to advertise the Banana Barboff side meeting, whatever it's?
Yes, it's a Barboff. It's tomorrow night. I will send mail to the mailing. Why don't I send mail to the Mptcp chairs to forward, because I don't think I'm on the Mptcp list, but I'll get mail to the Mptcp list some way.
Okay. So Banana stands for bandwidth aggregation something. So it's related to all of this stuff. And Olivier, I think probably 5 minutes you're now too, sorry.
Okay, 5 minutes. So the draft is a socket API to control multipass TCP. So if you remember what we did with multipass TCP, when we started multipass TCP, we said we will do something that replaces regular TCP and we keep the socket API unchanged. And that was the assumption that we had for the design of Mptcp and for most of the deployments until now. And if you look at the deployments that we have initially, so we expected to have a backward compatible replacement for TCP. This works, but I have to say that there are only a few people that are using Mptcp as a backward replacement for TCP. The use case that we see today, we have deployment where there are people that are using multipass TCP because it has very specific characteristics and it can use multiple paths. So one is Siri from Apple that you know. There are different SOCs deployment where they exploit multipass TCP to be able to use different paths, and the hybrid access network that Bart has mentioned before. So with the current multipass TCP, the user needs to control the underlying subflows. So how can they do that? If you look at the Linux implementation, the choice that was made in the Linux implementation was to take the management of the subflows in the kernel. And the idea was that developers would be able to add a new kernel module if they have new use case. It turned out that nobody implemented a new kernel module since 2011, and the 2 kernel modules that we wrote at the beginning have not been extended since then. So what was wrong with this approach? Well, the users need vary a lot. If you look at the developers mailing list, we often see requests from users saying, I'd like to do that, or I'd like to do this crazy stuff, or I'd like to do something strange. I have a situation where I want to use this link, but only for short flows. I want to use another link, but only for long flows. I want to use this link only when it rains, and things like that. So writing a path manager is difficult. And if you have to ship a kernel, we all know that even those who were at Quick this morning know that shipping a kernel is difficult. What's the other approach? There is another approach which is not documented, which is the one from Apple. But since Apple is open source, you can find open source files that use the Mptcp API. And what they do is that they create a socket with a new address family, because their use case is for a single application, so they don't want to use Mptcp for all applications. And they have special system calls that allow you to attach a subflow to a given Mptcp connection. And I think, given the use case we have, I think it's time to work on a standardized Mptcp API that uses socket options, and to start with socket options. Why starting with socket option? This is what was proposed in RFC 6897, but was not implemented until now. But the advantage of socket option is that it's very easy to pass information and to get information through get socket option and set socket option. And developers are used to play with that. So we have implemented, Benjamin has implemented Mptcp socket options that allow to retrieve the ID of the current subflows, because in Mptcp, the number of subflows that you have for a connection can change over time, because it depends on what happens in the network. You might receive a reset, or you might receive a SYN. The change is the number of subflows that you have, so there is a need to get the number of subflows. There is a need to do the equivalent of get peer name and return the endpoint of a subflow. There is a need to create a subflow. There is a need to close a subflow, and there is a need in some case to be able to apply some options to some specific subflow, or to retrieve options from some specific subflow. Well, everything has been implemented. There are examples in the slides. I don't think we need to look at the examples here, but everything is implemented and running. So that's implemented in Linux. So we can do the basic control with socket options. We are now working on doing more asynchronous events to receive message and send message, so that we can collect information about changes in the stack while we are sending or receiving data. And that's important if you want to be informed about what's going on in the underlying stack. And what we expect is to do cooperation with application developers to first better understand their requirements, so how they would like to control the underlying TCP connections, TCP flows, and understand what are the right abstractions that we can expose. So as network researchers, we would like to get information about everything in the stack and expose it to the API. I don't think that application developers need to understand everything, so we have to look at what are the abstractions. So next step proposed for the IETF would be to add the socket API to the working group charter. It's not currently in the charter. And if it's in the charter, I would ask the question of working group interest.
So I was under the impression that the IETF does not do an API, will not do a socket API.
Well, there is a socket API for SCTP. There are sockets API for some stuff. There was an API discussion this morning for Quick. You never know what can be done and what cannot be done within the IETF. What I know is that I know it's important to have an API which is shared by all the implementers. So if the IETF tells me that we don't want to have an API, I would say fine, provided that we can discuss with you, Apple, Oracle, and Linux, so that we work together and have a common API. And that's the main important thing for me, it's to have a common API.
Alan Ford, yeah, I didn't think we did it either, because in the first iteration of this working group, we decided we couldn't specify an API down to this level because that wasn't what the IETF did. So we wrote 6897. If the decision is that 6897 doesn't cover all the functionality we need, then you should be proposing this as an update to 6897.
It could be.
I was particularly confused reading it, since it doesn't comprehensively cover all the terminology, all the things that were identified in 6897, and the bits it does have gone off and used different terms. I think it would be much more valuable to if you feel 6897 doesn't do the job well enough, then this should be an update to it and not a completely fresh start.
Tommy Polly, Apple. Mike. So regardless of whether or not the IETF should be specifying APIs, I think the the lessons here are very important to share in a document, to be able to say these recommendations around what an API should do. As someone who has adopted, deployed, has written code using sockets APIs that we have for Apple doing this, it is very tricky. And having more standard ways of doing that across the platforms is good, and giving guidance to people who are working on that is very useful. Regarding specifically the path management stuff you mentioned, looks like Linux has, more the kernel doing all of it. We have the user space doing all of it. Both, I imagine, are very problematic. Having the user space manage the entire path is really, really, really tricky. And so I would just to that end suggest, I like the socket options. If we're going to interact with it to open the subflow from user space, that's fine. But it'd be good to have all of the events of you are now eligible to open a new subflow. Those should come from Mptcp, and those should be driven up, because trying to figure out all of the things that all the events to make it a good time to create a subflow is very tricky, and the kernel is the one that knows best about that, and that should come up from the same source as everything else. So let's make sure that it's done.
Yeah, I agree.
Lorenzo Corelli, kind of related to that, I think, there's also some common work with protocols that, this is not the venue for it, but protocols that aren't Mptcp, that are multipath aware. And the problems that you're going to have with these protocols are pretty much the same. Like if you want to do multipath and quick, you basically have to key off of the same signals, make the same decisions with kind of similar data available to you. And quick is looking like it's all going to be in user space because various arguments. But it would be, have you considered making this more generic in terms of which events come in and how the stack would need to react and what opportunities it has? Another reason to make it more generic is that specifying an API is, at times is or at times is not part of the IETF charter, and sometimes we do it and sometimes we don't. But one answer that I've received recently about doing a sockets API in the IETF is that it belongs to POSIX and we can't do it. And so if you have a generic API which does not have any POSIX bindings, you can then standardize that without having to liaise with POSIX. So that was, if you have something more generic, you can also overcome that hurdle, particularly if your primitives map very closely to the POSIX primitives, you can effectively do POSIX API without actually.
Yeah, so I understand that it's possible to write a POSIX, a document that looks like a POSIX API, but is not a POSIX API, so that it can be accepted by the IETF. I'm not really a good specialist at IETF politics, and I don't want to be a specialist on that. I think what's important is that if we agree on developing an API, whatever we call it, I think it's important to get feedback from the application developers. And that's what Tommy mentioned about Apple. It gave them feedback, and by opening a Linux API, which might be primitive at this time and which might be socket-based, what we hope is to get feedback from the developers, and based on the feedback from developers, we'll be able to iterate. And I think it's by doing innovation and by iterations on the software that we'll be able to better understand what are the requirements. And this might become generic requirements for multipath application, and they might end up in another working group or whatever. But I think it's important to have something, a baseline, which is common for the different implementations. Otherwise, it will be very difficult for people to do experiments and to develop applications that run on top of multipath. And then where we put the final document, whether it goes in IETF or not, I don't know. We ask the ID.
Yeah.
The AD.
I agree. That's exactly. We should be getting feedback. I just much rather see it as feedback against our existing work rather than trying to start from scratch on this and get feedback on 6897 and provide updates where possible.
Yes, but if you look at 6897, basically in 6897, you do more or less that. You don't do get socket option and set socket option,
No. So,
but you do more or less the equivalent of that. The difference between 6897 and the status now is that the status now has been implemented, and by implementing the stuff, we have found that there are some corner cases that you need to take into account that were not specified in 6897.
That's great. That's why I'm saying this should be an update to 6897 and not a fresh document.
It could be.
Walter Kulten, Soft at Home, fully support this idea. There are various needs for this. The RFC that describes the socket API of SCTP doing similar things is linked from the draft. I've read it. Is there, not a criticism, just a question, is there a reason why this API looks so much different from the one that was chosen for SCTP?
It's just so it's a result of a first implementation to see what can be done, and then it's a baseline for discussion with other operators, and then other implementers, and if we can agree with other implementers, then we will specify a common API.
Yeah, sure. The question was more, there is an SCTP API out there which is documented. Is there a reason why you concluded, did you look at that and say that let's try to mimic that as closely as possible because it's a known API and somebody's implemented it?
We have looked at the SCTP API, but we have not tried to mimic exactly the SCTP API because SCTP has different problems with the support of different streams that we don't have in Mptcp, so we cannot do exactly the same stuff as in SCTP. And we prefer to start from something from scratch instead of trying to copy SCTP and try to reuse some part of SCTP. In the end, if we have a solution that works and that looks like SCTP, then it means that the SCTP API solution is something reasonable, and then we can converge to the SCTP solution. If we go in another direction, then it will be a lesson saying that we should do something else than SCTP.
Okay, thanks.
Well, I'd like to thank Philip for allowing me to waste 5 minutes of your time.
Thank you for coming.
So I work on NFS. My colleague Andy Adamson works on NFS. I work on sort of a lower level RPC over RDMA transport. Andy works on the upper level. He's been looking at Mptcp for solving various problems with NFS for several years. And I thought there's some common interest with having multi-connections for RDMA transports as well. And we see an opportunity with some of the API work, being able to look at various subflow characteristics might be appealing. So I'm going to walk through a couple of slides that describe the issue and see if there's anybody in the room who's interested in following up, and we can have a meeting later to talk more in more depth. So that looks right. So about 6 years ago, RFC 5661 came out. This is NFS version 4.1. Introduced this idea of called sessions. It's actually common in the storage protocols. SMB also has this. But the idea is a replay cache is created on the server that enables exactly once RPC execution semantics. So the server can, it's a bounded cache, so you can't run out of cache space and send RPCs that don't have a reply anymore. It's basically, there's a retirement mechanism, so each RPC is executed for sure. It outlives transport connections, so the client can close a connection, open a new one, and say, I'd like to talk to this session ID again, and it has the same replay cache in it. So it pretty thoroughly solves our exactly once RPC semantics, which is important for item potency of execution. So each client can create one or more sessions, and each of these sessions can have one or more transports bound to it. So what we're specifically interested in is trunking, which means having more than one connection between a client and server. And I think everybody in the room understands what the value is there. You know, having the ability to failover between paths and having the ability to run parallel connections at the same time through multiple NICs on both the server and the client. We also have the ability to support RPC over RDMA, and there are hybrid arrangements where a client might open some TCP connections to the server and some RDMA connections. So we're kind of interested in merging those together, even though RDMA doesn't use sockets. I think that's something that we could discuss. One thing we don't have in NFS is a native facility for server interface discovery. I think Mptcp might provide that. SMB does, and we kind of realized too late that this is an important feature that we need for multipath. So there are three basic forms of trunking in NFS. The top one is PNFS. It's kind of an implicit form of trunking. We don't really call it trunking, but PNFS allows multiple connections from a client to one server or multiple connections from one client to many servers. So the second kind of trunking is client trunking. That's where the client would create multiple sessions. In other words, multiple replay caches. And one of the things it could do is create a connection and session per mount. Or another one, it could run all I/O operations, that is reads and writes, through one session, and metadata operations through a second session, and lease management through a third. Then the third form of trunking is session trunking, and that's when we have one session per client, but it connects to that session with multiple transports. This is the Linux choice is session trunking. Andy is working on that right now. My employer, Oracle, is looking at client trunking for Solaris. By the way, that's not a product announcement. I'm just saying. So as I mentioned before, we've been sort of looking at Mptcp and the capabilities because there's some good fits between what we would like to do with the NFS client and what Mptcp can provide. But there are also some places where we think we're missing a little bit, or maybe there's some things that are in development here that we'd like to learn more about and discuss with you. So one that's near and dear to my heart is RDMA is not included. I'm not sure if you're thinking about that or if someone has already thought about it and said, well, that's a silly idea, we're not doing it. I think the bottom two bullet points were addressed by Olivier's talk, so I don't really need to go into more detail there. But so anyway, this is generally what we're thinking about, and we're just wondering if anybody would like to come talk to us about it. Andy's going to be around about 16:30 today, and he'd like to join the conversation.
Yeah. Just one clarification question about, when you are mentioning this bullet about only TCP transport are supported, that means that you need other transports?
RDMA, yeah.
Okay, so the plain mode can be your help.
So the RDMA you're talking about is, right now you probably use InfiniBand, not TCP over RDMA?
In fact, the RPC over RDMA protocol is agnostic to the underlying fabric and transport. It's written to the generic verbs API. Okay. So we can use Rocky V1 or V2. We can use IWARP. IWARP is probably where you could fit in Mptcp.
Okay. So that's one of the use cases that we were saying. We also look at some database applications where they're running on InfiniBand, but they want to run on TCP, and we want to encapsulate the packet. That's why we are talking about adding header to the clear mode of what.
Yeah, so I agree for the last 2 points. The socket API would be a nice point. Discussing with users of Mptcp, I got one feedback one time from someone who was using Mptcp with CIFS, the distributed file system. And what he did is that he created a loopback interface, which is announced over a routing protocol. And then he used them so that he makes sure that the loopback interface is always up. And then he used Mptcp to use the different physical interface and to advertise them. So it goes back to your question of advertising addresses. And he did that with the unmodified Linux implementation of Mptcp. But now with the socket API, you could do much better on controlling the routing and getting information about the subflows.
Right.
But we can discuss offline.
I mean, one thing we talked about is there are some ways we can use NFS protocol elements to have the server advertise addresses, but that list would have to be populated somehow.
Yeah.
And Mptcp seems like it does all this
It does it
quite
automatically.
automatically.
Yeah, automatically.
So what would happen if the server advertises some addresses? What will happen with the permissions and things like that for NFS mounting and reading and writing?
Well, this would be probably more appropriate for a Kerberized environment where the access list is open to anybody, but you got to have a Kerberos credential to talk to the server.
So, well, thank you for coming and advertising. I mean, this was let's say it was an advert to kind of bring up this issue and find out if there's interest from people in the room in discussing further with Chuck and his colleague. So I guess the easiest is to have a show of hands. So if you'd be interested in having a further chat, maybe later today about this stuff with the NFS guys, do you want to stick your hand up? So
yeah.
there's
I'll be here
Ned and
to the end of I'll be here to the end of the session, so you can just see me afterwards.
Your suggestion was 4:30 today?
And that's when Andy's coming back, but we could do it anytime.
So anytime. So maybe
After he's back.
maybe the people who are interested just gather at the end of the meeting, and we'll work out a time and place we're going to meet.
Okay.
Okay.
Thanks.
Because it was about 6 people, wasn't it? So I think we can cope with gathering at the front. Right, Rooney, you're up. Thank you very much. So you have less than 5 minutes.
Less than 5.
Yeah. Give us the highlights.
Hi, I'm Rona from University of Oslo. This work is basically linking the window during slow start in Mptcp. Okay, so this draft is the update, and we have a published paper. We implemented this Lisa in the Linux kernel, and all the information is on this website. Sorry. And then we presented this work in Yokohama. Okay, so regarding the Lisa, what is it exactly? So Lisa is very simple. It is just an object to the first slow start of the new soft flow who joins. Okay, so what do we do in this? Let us say when a new soft flow joins, at that time we need to decide what is the window size, initial window for this. So what do? We know that we have already the initial soft flow. So if it has, let us say, enough window to give a share of it to the new soft flow, then we can take from it and we can adjust accordingly. This is like for all the soft flow. So after some time, let us say a new soft flow joins and no soft flow is in slow start, then we can just follow these standards based on the algorithm of Lisa. And why we do this? Because we try to reduce the temporary aggressiveness and the losses at the end of slow start. So why we thought of the solution, thinking that assume that there is a shared bottleneck and all the soft flows share the link, so it is a problem for them. Then starting with that, then we thought how, because in a realistic scenario, maybe there may not be shared bottleneck. So we analyzed the results of that. Okay, so in the last IETF 94, we got the feedback as like, this is the feedback we got. So, and it was asked that to check with different BDP, and does it improve or not, or any effect. So what we will show this presentation, basically we try to study Lisa performance in shared as well as non-shared bottleneck. What we have 3 variables, like 3 directions we are working on this, like let us say varying the number of soft flow, then RTT, BDP, bandwidth, and then we saw Lisa, mostly Lisa works better for small flows, but we need to see, does this has any influence on the larger transfer or not? So just so that we can understand that LISA does not adversely affect, but it has some improvement or not. Okay, so for this, we took a shared bottleneck where it has only two interface, so two soft flow we created, and this is the bottleneck. In non-shared bottleneck scenario, maybe these links are bottleneck, but there is no common bottleneck between this. So this case we studied.
I suggest you move to your result.
Yes, yes.
Yeah.
Okay. Okay. So this is regarding, we want to see the performance for varying number of soft flows. This case is for RTD, base RTD is 40 millisecond, 5 Mbps, and we vary the size, the transport size as 50 to 1000 kilobyte, and we can see the performance of LISA over Mptcp without LISA. And what this is only for two soft flow. So we can see that there is an improvement. And what we can see, we talked about that when there is a slow start, like end of slow start, there is a big difference in the number of retransmissions actually, what we get benefited by the LISA actually. And this improvement becomes larger when there is a large number of soft flow. And this is only two soft flow, this is four soft flow, where we can see that there is actually improvement in the mean completion time. This is a transport mean completion time. Then we can see that the number of retransmissions also for four soft flow is also quite improved actually. And in a data centers, like minimum 8 soft flows. So in that case, in the paper, it is mentioned that even we got better improvement to this. Okay, then that was about increasing the number of soft flow, how the improvement is there with LISA. Then we can see, let us say, with vary the RTT when to see a large BDPs. So what we took, the bandwidth is same as 5 Mbps, but we vary RTT as 120. So we can see that with respect to the file size, okay, there is a problem here. We can see this, okay, this is basically why this is, it should not be like that. For example, let us see why there is an improvement here. There is a bad effect here. For example, LISA is like, see, basically we are trying to reduce the aggressiveness, but still, if you have enough BDP, they are going to grow anyway. So that's why if this is the sum of the window size of the two soft flow, and we can see that this is the BDP, and what happens here? Anyway, the summation of the windows, total window is going to be increased because you have enough bandwidth, and that makes maybe it will behave the same thing. It may cause the same loss. So where there is a delay. So for this transport size, there is a not improvement, rather it is opposite. So obviously, so this is a rare case that when there is a, anyway it will hit the buffer. So that's why this case, but whereas this case, we can see that there is an improvement in LISA.
So
okay.
I'm very sorry, but I want some time to talk
Okay.
about recharging.
So I'm going to finish soon.
So can you spend 10 seconds wrapping up?
Okay.
Do you have your conclusion?
Okay. So non-shared, but okay, this is regarding
Is this the
RTT.
slide you want?
Okay. Okay. This we started for RTT,
No, hang on,
different bandwidth. This is for non-shared bottleneck. What we see in the non-shared bottleneck, we vary the same RTT case. We can see that the performance, there is something, at least improvement. Here there is no major problem because you have enough BDP, so we can't see this. So then we vary the the capacity. We can see there is not much difference between these two cases in non-shared bottleneck case. So then what we see is that for large transfer, we want to see, does this have effect or not? Then what we see for large transfer, we want to analyze because of mostly
So,
the LISA's improvement.
I'm sorry, I'm really sorry. We're out of time, and I know that this is going to take a long time. So
yeah,
I think we're going to have to gather in a different corner at the end of the room and have the discussion about it and go through the slides. Because I want a little bit of time to talk about recharging. And
okay, I was going to offer a one sentence conclusion of this thing, but okay.
One sentence. Well,
so this reduces the burst that you have in one particular RTT when new subflows join, and you have many subflows, all clocking all the initial window of 10 at the same time, and that is, reducing that is a good thing when you share a bottleneck. When you don't share a bottleneck, it more often than not also is a good thing. And
doesn't really seem to harm much. That's our conclusion from doing these tests.
So I'm sure the people want to talk about it more. Gather at the end. Yeah. Thanks, Runa. Okay, so oh, is that what I want? Yes. Okay, so two things have come up to do with which are not on the charter, which there seems to be interest around. One is around the socket options, and one is around proxies. So I've put up on there what our draft currently says, our charter currently says about proxies, which is basically that one end, so one of the end hosts must be Mptcp enabled. So the scenarios we've heard about earlier, which have a proxy at each end, so both at the CP and at an aggregation point in the network, are not in the scope of the current charter. And to be honest, we've had we had some drafts maybe a couple of years ago which were sort of towards what the charter says, but we haven't really had any work since. So my feeling is it's a bit pointless having a charter that doesn't correspond to what people are interested in. So we should either delete this item completely or else amend it to be about what people are actually working on, which is the two-ended case. So the mic is now open for anybody who wants to give their views on whether we should adapt the charter to allow a two-ended case or anything else that you think should be on the charter. And we've got just about 10 minutes to talk about it. So we're not going to get to the end, but we can start discussion.
Lars Eckert, briefly, I think the NFS discussion might turn into something of a rechartering discussion where we say maybe there's something that we need to do in order to allow use of Mptcp applications that have special needs or are need fuller control than we thought they might in the past, and it ties in with the extended API. That was number one. Nobody will be surprised that I'm standing here to talk against the proxy stuff, right? I understand that operators want to do multipath and they want to combine stuff. And just because we've done multipath TCP and it's sort of, it has the word multipath in it, doesn't mean that it's a particularly good solution here. And I don't see it, I don't think it's productive to do that work. It seems to twist the protocol into ways that it wasn't meant to be twisted in. And if you need a screwdriver and you have a hammer, tough luck.
Yeah, so no surprise that I will disagree with what just Lars said.
This is Ned.
Yeah,
please remember to say that.
So I think that's, there's a group of people who are very interested, and there is a good energy in working on this proxy stuff. I think that this is a good signal for the IETF. There are deployments which are using Mptcp proxies, so we have to acknowledge that. We have to accompany and to provide guidelines, a common solution to these people to avoid having multiple Mptcp-based solutions. This is the work the IETF is supposed to do. Mptcp is an experimental RFC, so we can continue in that direction to experiment with Mptcp proxies. We are not asking to have it as a standard track. I am for modifying this paragraph so that this is explicit, that we can have two proxies or one proxies, or having the proxies in for the hybrid access or for the data center, whatever use case that people can be interested in. So having a generic text to allow having documents that will specify the proxy stuff. There are other items that I am interested in for the proxy stuff, which is the management aspects, the Young model, and the provision of the consent writer to the CP. I would like to have these items also added to the charter.
I just wanted to clarify that even with the dual proxy scenario, we actually also cover in the current refs, or want to cover the scenario where actually one site is already Mptcp capable. I mean, it's something that we have to do anyway as a matter of interop when the end user equipment is already doing Mptcp on one site. So what is being worked on with the combined refs will somehow also cover then the case and the initial charter for network assistance scenario.
So, Olivier Bonaventure, let me disagree a bit with Lars. So I was involved in the Mptcp work, and when we started the Mptcp work, my assumption was that we would get Mptcp end-to-end, and that this would solve many problems. It turned out that getting Mptcp end-to-end is very difficult because there are load balancers, there are crazy issues like that. And then the issue of hybrid access network came in, and a nice way to solve the hybrid access network would be to provide 2 addresses to the end host so that you have 1 address per link that you use, and then you would have a pure end-to-end solution. If you were in RTGWG yesterday, you could see that having multiple addresses per link at a home or in an SME is something which is very difficult and which doesn't work even with IPv6. Let's forget IPv4. And if you look at hybrid access network where you have a fixed network and a wireless network, it turns out that from a technical viewpoint, the ability of having an Mptcp connection between the CPE and the hybrid access gateway is the best way to react to reordering, to changes in bandwidth, to changes in delay over the different links. And you do not control any of the link because you can have changes in the DSL because you have a multicast that starts and you have a change in bandwidth and you have lots of changes. And the ability to react quickly is something which is important. And Mptcp provides that. And there is deployment that shows that Mptcp works in this direction. So that's a domain where Mptcp can solve real problems for real operators. And I think it would be a really good use case for Mptcp, and I think the IETF should be involved in that use case. Otherwise, we will end up in multiple proprietary solutions that will be incompatible, and we will have issues with that in the future because we will have even more middle boxes that are not documented and stuff like that, and we know what happens with middle boxes that are not documented.
Wim Hendricks from Nokia. I'm also one of the co-authors of the draft of the proxy, so I'm also in favor of that. And I think the fact that if you see how many contributors we have, both from the vendor community as well as from the operator community, right? And there is even people who have deployed it. I think it's important to have that as part of the charter to make sure that we get interoperability, because some of the operators, they want to actually pick and choose the CPE and the concentrator from different vendors, and they want to have interoperability and stuff like that. And there is already deployments out there which have proven that this works, although there is challenges and you have to deal with that. But I think given the amount of people who are actually on the draft today, it shows that there is quite a bit of interest to do this. And I believe in the IETF, it's important to make sure that we get interoperability and to avoid getting into all the corner cases.
Well, very good. So let's have a BOF in the int area, because this is not a transport thing anymore. If that's the sole use case that we're using the technology for, we are in the wrong area, and it's not a recharter. It's a new thing.
You know, for what it's worth, I agree with Lars that, you know, I think actually despite what I said earlier, I actually think Mptcp could be a really interesting technology for this. I want to understand more about it, but it's not like the, you know, tunneling proxy solutions, middle boxes that do that sort of thing are not, like, this would be a surprising place to be doing standardization of that.
I was surprised, Rolf Winter. So I was surprised that you didn't mention banana at this point, because you mentioned above. There were a couple of side meetings already. That might be the place to. I mean, there was a question in the banana group, I think, whether this should become above at some point in time. Maybe it should.
That will be discussed on Thursday night among the people who come, and I hope a lot of people from this room will come. We're going to be talking about Mptcp solutions, among other things. It's just a barb off. It's, you know, me and Minghui and a bunch of our friends. I mean, at this point, you know, but it could become more. There's talk about whether there's enough work there to warrant a working group, or whether we would try to bring the work to int area. I don't think it's been decided yet what the dispensation of that work would be, but it'd be nice if we could all get together and, like, do it together somewhere.
So it's your feeling that the group therefore there should be a single group that talks about the multiple, because there's multiple different approaches to bandwidth aggregation have been discussed, like in the banana meetings, aren't there, MPTCP and the IP layer solutions. So you think there should be one, if chartered work is done in the IETF, there should be one place that can cover all of those different types of solution potentially, rather than
how it's organized is not, I mean, I'm not an AD or anything, so it's not my decision. There are MPTCP approaches, MIP approaches, and tunneling approaches. I might be over glossing, but basically 3: GRE, MIP, and MPTCP. And there's a lot of trade-offs between them. And actually, we may want to standardize more than one, because for different operational situations, different ones might be appropriate, in my opinion.
And it sounds like those different possibilities should be talked about in one place rather than trying to do the MPTCP ones here. And
I tend to think so, personally, but that's not my decision. I'd like to see all 3 of them done, and I would like to see them done in places where we make sure all the right expertise is in the room and nobody's surprised to learn there's one over there, you know?
So we now have about 1 minute left. So Costin, can you make your comment very quickly, and then Mia will be the last, I'm afraid, because Mia's AD, so she gets the.
I'm just trying to understand what the proposed process here is. So we go into int area, and then they propose changes to MPTCP, and then we come back. I mean, it just doesn't make sense.
Now.
Sorry?
We're not going to do process.
No,
right.
no, but I think the natural thing is just to do this here, because if you want to change MPTCP to support this stuff, you're going to have to end up here, right? So what are you doing in int area?
Okay. Mia, do you want to finish as making an AD comment?
I wanted to, but now I have a question.
Oh, okay.
Because like what Olivier said, it actually sounds like you can just use MPTCP and you just want to have it documented so not everybody is like, people know what to do, how to do it the right way. It didn't sound like you need to change MPTCP. And now Costin said you have to change MPTCP, so that's my question.
Yes.
Yeah, but you can easily split this up because you even said this, like this option is not very specific to. Yeah, so you can specify the option here, but giving or documenting operational guidance on how to use an existing protocol for a tunneling use case is probably not this is probably not the right working group for it.
So I'm conscious that the time's now over, and I don't want to keep people who want to go and get cups of tea and cookies from getting them.
Yeah, just one question about.
So Mia, do you want to make an AD comment to finish, or should we stop?
No, that was the comment. So I agree that operational guidance, how to configure your meter boxes, or how to apply this to tunneling, doesn't belong in this working group.
So we'll finish the meeting there. But if people want to, lots of people want to continue the discussion. So I'm happy to keep discussing. But if you want to go, I think we ought to let people the chance of going. Right, Bob and Olivier, go on.
Yeah, so the question was related to the socket API. There seemed to be support for working on the API. So should we add this to the charter or not? On an API to control MPTCP. So
we've clearly run out of time, for which I apologise.
So can we put this to the mailing list?
We should. I think we should put some of these things to the mailing list. That one seems a completely separate one to the other topic. Meg mentioned some other things. I have no idea if they were. I guess they were related to this hybrid case. But if they're completely independent, we should also put those to the mailing list. Bob.
All I was going to say is, given the L4 I spoke yesterday, there may be a need to change or to create a scalable congestion control for MPTCP, but I don't think that's the first thing we should do. We should get TCP worked out first, but it will come up eventually.
Thank you very much, everybody. Sorry for overrunning. Sorry to people whose time got squeezed. If you want to talk about, Chuck, before you go, if you want to talk about the NFS MPTCP stuff, come and gather in this bottom corner so people know where to find you. I told you we had less than 5 minutes.